The diagram above shows a velocity time graph representing the motion of a car. Find the distance covered during the acceleration and retardation period of the motion. Now, the first thing you have to understand is that in a velocity time graph, the total distance traveled is the area of the shape that is formed. That is, look at the shape that is formed here. This is a trapezium. So the area of this trapezium gives the total distance traveled. But it's not every time the question will ask you to find the total distance. They can ask you to find anything. So here now the question says, what is the distance traveled during the acceleration? So you need to know the acceleration period. From here, this line like this is the acceleration period. So the area that is formed here like this is in this triangle. So during the acceleration period, the area of this triangle will give the distance traveled during the acceleration period. Now, and the retardation. Here's the retardation period. Now, look at this line like this. From where the car comes to rest like this. This is the retardation period. So the area of this triangle here will give the what? Will give the distance traveled during the retardation period. Then you can add the two together. Now, one more thing that the question did not ask. What if the question say during the constant velocity? What is the distance covered during when the velocity is constant? Look at this from here like this to here. The velocity remains 10. You can see the velocity is not going up like this. It remains constant like this. So from here, the shape that is formed during the constant velocity is this what? Is this rectangle. And that area will give you the what? The distance traveled during the constant velocity. But the question not ask. The question only asks us to find the distance covered during the acceleration, which is the area of this triangle, and during the retardation, which is the area of this triangle also. So we're going to find each separately and add together, and that's our answer. So now, if you bring out this triangle like this, you're going to see that you're going to have something like this. So from here to here is 10. You can see here you have 10. Now, what about the height of the triangle? You can see from here to here is just this velocity like this. This is 10. So here is also 10. So the area of the triangle is half base times height, right? So which is half times, what is our base? 10, right? Times what is our height, which is also what? 10. So 2 here 1, 2 here 5, and then here is going to give us 50 what? 50 meter, right? So if you bring out this second triangle also, which is the retardation period, like this. Now, the height of this triangle remains 10 here, right? Because look at it. If you choose it here, it remains what? It remains 10. Now, what about the base here? Remember, this is increasing by 10 seconds. From here to here, 10, 20, 30, 40, 50 here. But then this thing stops at the middle. At the middle. So you should know that it's just 5. So here is going to be what? 5, right? So from there, you can say area is equals to half times base times height, right? So which is going to be equals to half times, what is our base now? 5 times, what is our height? 10. So 2 here 1, 2 here what? 2 here 5. And then 5 times 5 is going to give us 25 what? 25 meters. And then what is going to be the total distance now? That is acceleration and retardation. So the total will now be equals to the 50 for the acceleration plus the 25 of the what? Of the retardation, which is going to give us what? 75 what? 75 meters. That's our answer.